Hey, good morning, good afternoon, class. How are you? Man, we're getting there. It's already what? Middle of March, a couple months left. So you guys have done a great job. I know it's been difficult sometimes sitting at a computer all day and doing it, but you guys are really doing a great job. So it doesn't go unrecognized. So thank you for all your hard work, and let's keep going at it. All right? All right. So we have to find the y-intercept first. So remember, this is the y-axis and this is the x-axis. And we need to find the y first, so it's 1, 2, 3, 4. So it's 4, right? So let's put our dot here. And then we need to find where the line goes right through the corner of another square. So it goes through right here, okay? So I'm gonna go 1, 2, 3, 4, 5, 6. So the rise is 6. 1, 2, 3, 4, 5. And the run is 5. So the equation is y equals 6 over 5x plus 4. Okay? What happens if you did it this way? 1, 2, 3, 4, 5, 6, a negative 6, and a 1, 2, 3, 4, 5. And you'd have a negative 5. Well, you know 2 negatives equal what? A positive. So it would work. All right? Let's go over to this one here. We have to find the y-intercept, and it looks like it's right here at -1. Okay, and we have to find right where it goes through the corner of another corner of a square right there. So the rise is 1, 2, 3, 4, 5, 6, 6 again. And you go to the left, and when you go to the left, it's a negative, so it's a -1. So it's y equals 6 over -1 x minus 1. That's the equation. And you could go down and you could go over. So it'd be -6, +1. It's the same thing. Okay? So let's go to this one right here. And now we have to find the y-intercept again, which is right here. So we know that that's a +1. And it looks like it goes through here. Let's find out. 1, 2, 1, 2, 3, 4, 5. So the rise is 2, the run is 5. The equation is y equals 2/5 x plus 1. Okay, so let's see if we said this one. The rise is 1, 2. 1, 2, 3, 4, 5. Yep, you could done. You could have went either way. Nice. All right, let's go over to this one right here. And we have to find the y-intercept, which is right here. 1, 2, it's a -3. Find where it goes through. It looks like it goes right through the corner of that square there. The rise is a 1, and the run is 1, 2, 3, 4, 5, which would be -5. So you have y equals 1/5, but a negative, x minus 3. All right, nice job. Okay, now we get to put in our lines. All right, so y equals 3x plus 1. So we have to put in our y-intercept first. So here's it's a +1, so it goes right here, right? And this is the rise, so I can make the run, since there's not a number there, put a 1. So it's up 3 over 1. 1, 2, 3 over 1, okay? But I want 3 dots if I can get it. I can't go up 3 because there's no more grid. But the cool thing about doing this is you can change these numbers. So now you can go -3, 1, 2, 3, and -1. And there you go. Look at that. Pretty cool, huh? Okay. So This one here, y equals negative x plus 3. Well, if there's not a number, you can always put 1. So the rise is negative 1 and the run is 1. So we'll put in the 3, 1, 2, 3, the y-intercept. You go down, negative 1, over. Negative 1, over. Negative 1, over. And you can keep doing that. All right. And now this one over here is a negative 3, 1, 2, 3. That's the y-intercept, correct? And then the rise and the run is a negative 2, 1. So negative 2, 1, 2, 1. Okay, but we want 3 dots. Can I go anywhere? This way? Nope. So now we can flip it. Go up 2, 1, 2. That's a positive 2 and make it a negative 1. Up 2, negative 1. Up to negative 1. And look at that. Okay. All right, so negative 3 is the y-intercept, 1, 2, 3, right? And then the rise is 1, 2, 3, 4, 5, 1, 2. Okay, so this one's gonna be hard to get three dots, right? Because if I go up 5, I'm out, and if I go down this way, I'm out. So that's fine, we just go there, okay? All right, and this one here is a negative 4. 1, 2, 3, 4. And then up, I can't go negative, so I have to change this to a positive. 1, 2, 3, 4. And this was a positive, I have to make it negative. 1, 2, 3, oops, 3. Yep, so it'd be right there. And then draw your line, okay? And the last one on the sheet's a positive 4, y-intercept, 1, 2, 3, 4. And then I have to go up 1, 2, but I can't, so I have to flip it. 1, 2, and then since it's a positive 5, I have to change that to a negative 5. 1, 2, 3, 4, 5. In this one, you're gonna only be able to get 2 dots. There you go. Okay, awesome. All right, so we're just gonna do 2 on this sheet, okay? Because we've done a lot so far. So we have to find the y-intercept. 1, 2 would be right here, right? So that's 2 again. And then we have to find where it cuts through the corner of another square. And the rise is 1, 2. And the run is 1, 2, 3, 4, 5, which would be a negative 5. Y equals 2 over a negative 5x plus 2, right? Okay. And the last one we'll do on this page, the y-intercept is... looks like it's right here. 1, 2, 3. This is 3. It looks like it cuts through right there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So y equals 8 over 3x plus 3. Awesome. All right. We need to translate these algebraic expressions, okay? So let's look at the first one. Subtract 2 from 4 times 9. Well, we know subtract is minus, and we know times, right? So now we sit there and say subtract 2 from 4 times n. Well, if I said 4 times n, because it says subtract 2 from whatever 4 times n is. So it would be 4n minus 2, or if you did 4 times n minus 2, okay? 2/5 of h is subtracted from 9. So 2/5, so write it out, 2/5, and you know subtracted is this, from 9. So 2/5 of h. Of usually means times in math. Okay, so this is 2/5 h. So that's what that is. It says 2/5 of h is subtracted from 9. So is it this way or is it this way? 2/5 of h is subtracted from 9, it would be this one. Okay, add 4 to 5 times h. Well, you know add is that, and then 5 times h. So what they're saying is, whatever 5 times h is, add 4 to it. Or you could do this. Q minus 7. Well, that's pretty simple. Minus is this, so this has to be just that. 6 is subtracted from 1/3 b. Okay, so let's see. They're saying whatever 1/3 b is, then you have to subtract 6. So this would have to be 1/3 b minus 6. The product means multiply. Whatever p and 9 are, is subtracted from 1/5 h. Okay, so the product of p and 9, so p times 9, is subtracted from 1/5 h. So it would be 1/5 h, whatever this is, subtracted whatever p times 9 is. Okay? Do you notice how I'm putting in the symbols when I read it? Because math is a language. You have to understand the vocabulary that you're reading. So we said product is what? Multiplying, right? Of 3 and q, so you know it's this, right? Added's that. 1/4 m. So now I reread it. 1/4 m is added to the product of 3 times q. Okay? So you could say 1/4 m, right? Plus 3q. But you could also do this, because you guys are learning the associative and commutative properties. Couldn't you do 3q plus 1/4 m? You could, okay? 9 is added to f. Well, it doesn't get easier than that, right? 9 is added to f. 9 times the sum of y and 2. So whatever y and 2 is, you have to multiply it by 9. You could do it this way. It's the same thing. Okay? Remember, whenever there's a number next to a parenthesis, no symbol, you always multiply. Okay? And 3/5 of the sum of 3 minus the product of 2 and p. Whew. All right, there's a lot here. Okay, so let's reread this again. 3/5 of the sum of 3 minus the product of 2p. Okay, here we go. So we would have to say 3/5 of the sum, so that would be parentheses 3 plus w minus the product of 2p. This is a good one right here. This is a thinker. So 3/5 of the sum of 3 and w, so whatever 3 and w is, minus the product of 2p. So whatever this is, then you have to multiply it against that. This is a good one. Okay? All right? So now, all right. So I call these fraction boxes. All right? It seems like every year students get these on some variety of a different tests, and they seem to be confusing to students, but let me break it down to you to kind of show you that it's not. So basically, find the fraction in each row. This is how you do it, okay? Because when I look at this, I would have no idea either, okay? But watch how simple I'll make this for you. So just let's look at the first row. How many boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So that would be your denominator. And how many are filled in? 5. So the first box is 5/10. That's simple, right? I'm sorry, not the first box, the first row. So the second row then has 1, 2, 3, 4, 5. Oh, so that denominator would be 5. And how many are filled in? Well, 2. Okay. And the last row is 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10. And how many are filled in there? 9. Okay. So the last box is the answer. Okay. So the answer has to be 9/10. So you know the first box is 5/10 and the second box is 2/5. So what they're trying to get you to do to figure out is, do you add this or do you subtract this to get to 9/10? So let's do the subtraction of 5/10 and 2/5. Okay? Let's subtract it. Remember, the last row is what it's supposed to equal. So when adding and subtracting fractions, you need a common denominator, right? So that would be 10, okay? 5 times 2 is 10. Whatever you do to the bottom, you have to do to the top. 10 times 1, and whatever you do to the bottom, you do to the top. Well, 5 minus 4 is 1/10. Is that bottom row 1/10? No, it's not, okay? So now, let's try to take 5/10 plus 2/5 and see if we end up with 9/10, okay? What's the common denominator? Well, we know it's 10, right? 5 times 2 is 10. Whatever you do to the bottom, you have to do to the top. 10 times 1, whatever you do to the bottom, you have to do to the top. 5 plus 4 is 9. So you would say that you would have to add 5/10 plus 2/5 to get 9/10, okay? So once again, once you just do the first row, figure out the fraction, the second row, figure out the fraction, the last row is the answer. You just have to figure out, do you add or subtract it, okay? All right. Find the volume of this triangular prism. Okay, so it is the area of the base, okay, times the height. Okay, so when we look at this, the way it's laid right here, do you see this down here? That's the base right now, but you need 2 congruent sides. So you have this rectangle here, but is there another rectangle across the top? Nope, it's not. So you'd have to stand this up so this is standing on its bottom and this would be the top. Now it's 2 congruent sides, so this would be the base because it's standing up, okay? And what shape is that? That's right, it's a triangle, okay? You can write it 2 ways. So the base is 10 and the height 6, okay? What's 10 times 6? 60. And what's half of 60? 30. Okay, let's just do it down here. 10 times 6 is 60. And then half of that is 30. So you know the base is 30, right? Now remember, this is standing up. So this is the base. So this would be the height times 20 is 600, okay? So now, let's find the surface area of this triangular prism, okay? So if you guys remember, right, way back, we did stuff like this. And if you found the area of this, it's a 4 by 3, right? And whatever, and that's 12. Well, if this one's 12, this has to be 12, right? Because it mirrors it. Does that make sense? So that would be 24. Let's do the bottom. The bottom is a 6 by 4. Well, if the bottom is 24, then what's the top? 24, okay? So we're gonna do the same thing here, all right? So let's find the triangle. We know that it's base times height times half, which is 10 times 6 is 60. And then half of 60 is what? 30. Well, if this is 30, what's this one? 30. So we have 30 plus 30 is 60. So we're done with that. All right. Now we're going to do this piece. So what is it? It's an 8 by what? That's right. It's an 8 by 15. So 15 times 8, 5 times 8 is 40. Carry the 4 is 120. Well, if this piece is 120, then what is this piece? It mirrors it. That's right, it's 120. Okay, and now we just have the bottom piece. We have this piece right here. Here, I'll shade it in for you so you can see what I'm talking about. That piece. So you can see it's a 10 by 5, right? So that'd be 150. So now, do we have another one that mirrors that? No, we don't. Okay, so you take 60 and 240, which is 300, plus the 150, and it's 450. All right, superstars. Have a fantastic day.